Hi, everybody. This is Nalini Elkins with Industry Network Technology Council. Welcome to the webinar on the DHCPv6 Lab. If somebody can send me a quick note to let me know that you're hearing me okay, that would be wonderful. Perfect. Yep. Great. Thank you so much. So we are recording this session so that if you'll have it afterwards. And there's a lot of great material, so you're probably going to want it. Okay. So as probably all of you know, this is a collaborative project with the India Internet Engineering Society in India and the INTC, which is in the United States. We are both nonprofits, and today we're going to have somebody from the Indian group presenting, so that will be great. Our funding is from ISIF Asia, part of APNIC. Thank you very much. We also have funding from Aaron. So let me go forth. This is a multi-year project. Let's not talk about how many years. To promote IPv6 deployment at enterprises. It's a very important thing, and as most of you probably work for large or medium-sized enterprises, you can see that you probably have many questions. And so one of the big things is to provide training for the people, for the technicians, because it's very hard to go forth if you don't know what to do, and hence this whole project. And we are also working with security and application problems that you'll have, and you'll see more on that later. Actually, I'm getting a question about if there's been contact with NIST in the United States government. And yeah, very, very good. We're in very good touch with NIST. I haven't looked at who's attending right now, but oftentimes they attend as well. I know they're wanting to do stuff in this space as well, and we are working very closely with them. We know them quite well. So, okay, we have done quite a few classes in this whole area, and this one is the V6 Lab. A couple of words about me, and I'll just keep it really brief. I've been in this area for way too long, but still get up in the morning wanting to keep going. Yeah, as I say, I'm really ill. I love this stuff. So let's talk about the presenter today, who is Mohit Taliani. He's Assistant Professor of Computer Science at NITK, which is near Bangalore. And he is on the board, I believe, of the India Internet Engineering Society. He's done stuff with NS3. His work is mostly in the whole TCP and traffic control modules. He's a part of IIEE and done quite a bit in that whole area. And now he is wanting to learn and teach IPv6 at NITK, which is absolutely wonderful. And he will be the one that is doing this presentation. So let me now make him presenter, and he will take over. Thank you so much, Mohit.
Oh, thanks, Nalini. Can you hear me okay?
Yes, we hear you perfectly.
Okay, and are my slides visible?
Muted. Unmuted.
Can you see my slides?
Yes, sorry, I muted myself, and so I can, yes, okay. We see your slides perfectly as well.
All right.
Yeah.
Thanks for the introduction, Nalini, and thanks for the opportunity. Thank you, everyone, for joining this session. Here is a brief agenda that I plan to cover in today's session. Of course, there is a lot of things. There are a lot of things that we can actually do with DHCPv6. But keeping the time that we have for this session, I have just chosen two main things to be shown in this particular presentation. The first thing that I plan to cover is the address assignment using stateless autoconfiguration. And since I'm not using any actual router machines, basically I am just setting up a couple of VMs in my machine and then trying to use it. I'm going to show you how did I set up a simple radvd, which is the router advertisement daemon, a software which we can install it, and then we can send the router advertisements through a specific interface. And once we complete setting up that, we will go and see the PCAP traces. We will try to see the router advertisement messages and the neighbor solicitation messages that are exchanged between the two devices or the two virtual machines that we have. And then I'll also talk about the radvd configuration, that it's relatively a small configuration file. And I'll just point out how we can go about changing the prefix and then just restarting the radvd, so that if you would like to assign a different set of prefix, that can be done. Once we complete the address assignment using SLAAC, we will move to the stateful DHCPv6, in which I will again spend some time on explaining how do we set up a DHCPv6 server. There are many ways by which we could do it. There are many tools that allow us to do this. For example, there is Kia, which can be used as a DHCP server. There is Dibbler, but I'm using a very simple one called ISC DHCP server. It's relatively easy to set up, to play around with it. Like Nalini already mentioned, that at NITK we have started efforts to learn more about IPv6 and slowly migrate to IPv6 if possible. And then it was important for us to get started with small experiments at hand so that we can understand this whole thing in a better way. Then once we do that, we will move forward and we will see how do the two machines exchange the solicit, advertise, request and reply messages, which Nalini covered quite a bit in depth in the last week's session. Then again, we will look at the DHCP daemon for v6 configuration file and see what are the things we have inside that if we would like to change the prefix. Then I would also walk you through a DHCPv6 lease file where we can see exactly what are the leases given. So how many clients have been given IPv6 addresses, what's the validity of those addresses, and when did it start and when does it expire. Logs are very important for debugging purposes. So we will also take a look at a sample log file which will be generated in the process of our experiments. So this is the main agenda that I plan to cover. Let's get started with this. First one, we'll talk about address assignment using SLAAC. Before I go into the specifics, just to give you a quick idea about what is the setup that I have. So you can see that I have a client machine and a router machine, and I call the client interface as CR just to represent that it's an interface that's going from the client to the router. Similarly, I have another interface at the router which I call it as RC just to represent that it's going from the router to the client. And I have named the Ethernet devices also in such a way, as you can see in my second bullet down last in the slides, that I have named them as ETHRC and ETHCR, so that when we have to check whether the IPv6 addresses are correctly assigned to a specific interface or not, it's easy for us to just play around with it. Well, I found actually two different approaches by which this experiment could be done. I have done it using, right now in this particular session, I'm going to demonstrate this first one where I have set up two virtual machines in my server here at the university. And one of them is configured as a client, as you see, and another one is configured as a router. And I'm going to install the router advertisement daemon on the router interface, and this will assign IPv6 addresses in a stateless manner to the interface on the client, which is represented as ETHCR. Now, there was another approach also that I found useful, and I thought I should mention it at least during this session if there are people who would be interested to avoid setting up virtual machines and rather just play around with network namespaces. So that's also possible, and I tested this whole setup by just creating two network namespaces using IP route 2, and I could see that it was much lightweight experiment as compared to the two virtual machines. And I have a certain steps noted down for this approach as well. If somebody would like to repeat this experiment, what I did on virtual machines, but they would like to do it instead on network namespaces, there are a set of steps that I have prepared, and I'll be sharing all the material after this particular session, including the presentation slides. So let's go ahead and now maybe play around with this two setups. So as I said, I'm going to talk when I have two different VMs, one of them as a client and another one as a router. So what we need to do is we need to install the radvd package, and it's a simple thing that we can do it from ubuntu apt-get. But before we do that, it's always better that we set up a radvd configuration file and we just put it in etc. So I go to the etc, I create a new file called radvd configuration, and then I put up this small set of lines that you see in front, that actually forms the radvd.configuration file. So you can see that we need to specify the interface. So I have highlighted that in a different color, that this is the ethrc interface that is going from the router to the client. And there are a bunch of parameters that you see that we have put up here. Let's go over them one by one. So the first one is the minimum time interval between the router advertisements, and the default values in the kernel are different, but I just, for this example purpose, I have just put up here that 3, and all the units are in seconds. And similarly, I have set up the maximum time interval between router advertisements to be 4. And actually we can open up the PCAP later and verify that indeed that the router advertisements are being sent at this frequency. This is an important parameter, the third one, which is called the advertise send, the ADV send advert on. It's basically a flag through which you can enable and disable the periodic router advertisements. And of course, we do not want it to be disabled, so we have turned it on. The next bunch of lines explain about the prefix. So you can again see that I have just configured a simple prefix here. And there are two important parameters that I have put up. One is the duration for the validity of the prefix itself, and the duration for the validity of the IPv6 addresses that are provided through this particular radvd software. So all of this is already set in my machine, but I'm just going over it so that it's easier for anybody to follow, just in case if somebody is trying to repeat this entire exercise. Once we do this, one important thing to note is that I do not have a dedicated router machine. So what I'm doing is I'm just creating two VMs, and it's important for me to enable the forwarding on the router interface. So what I do is I just set the forwarding equal to 1 so that that particular virtual machine can actually forward the packets, which is the typical responsibility of the router machines. And after finally I've done with all these things, I install the radvd package using a simple command called sudo apt install radvd. And then I have just listed these two basic commands, which are useful for starting the radvd service, or we want to stop the radvd service. At this point, I would take a pause and I would just go to my terminal and then start playing around and just show you the setup that I have with me. So you can see that I am already logged into my virtual machine, which I call it as a router. I also have another tab in which I am already logged into another machine or a virtual machine, which I call it as a client. And before we actually do any experiments, as I said in my presentation, I have all the configuration files set up in my machine. I have already installed radvd. What I'm just going to do is show you how IPv6 addresses get allotted to the client machine. But before that, let us take a moment to see what are the current IPv6 or IPv4 addresses that are assigned on the client interface. So I use a simple command IP space A, and it shows me the bunch of interfaces that I have, starting from the loopback interface, the other interfaces which are needed. But the most important interface that's needed for our experiments is ETHCR, which is from client to the router. And you can see that it has an IPv4 address, and then it has a link local IPv6 address. We can, this is an alternative command, and I can repeat the same thing by just giving ifconfig, and we can see that we have this ETHCR interface, which has an IPv4 address and which has a link local IPv6 address here. So this is about the client interface. Now what we want to do is we want to assign an IPv6 address to this interface by turning on the radvd software in the router machine. So let me just clear this off, and I'll go back to the router interface, and I will start the radvd service using the same command which I put up in my slides. So I'll say sudo service radvd start. And once it starts, of course, we don't see the packets going on here, but we will do that in a moment. We will go to TCP dump and we will start capturing the packets and start playing around with it. But let's go to the client machine. And now again, let us do an ifconfig to see what happens. And now we can see, yes, there is an old IPv4 address which was assigned. This is the link local IPv6 address which we know it already had, but this is the new IPv6 address which it has received with the global scope, you can see. And that's depending on the prefix that we had actually configured in our configuration file. So if you would just like to go back to the presentation, you can see that we configured this to be our prefix, right? And according to that, we can see here that the IPv6 address has been assigned to the interface. I can also do one more thing. I can actually pick up this IPv6 address which has been assigned, and I can delete it to see whether my radvd is still working or not, because you can see that I have not yet stopped radvd from the router machine. It's still running on the router interface. So what I do here is I go to the client. I know that an IPv6 address has been assigned, but just for the sake of demo, I would just like to delete this IP address. So I would say sudo IP address delete this specific address from the device which is called ETHCR. So using this command, I delete it. All right. So okay. So let me just give me a moment. Yeah. So let me check this once again, and we have this address. Just copy it, and let me do sudo IP address delete this specific address from the device ETHCR. And it has deleted this address. But since the radvd daemon is still running, if you do once again a quick check with IPA, you will see that the address is reassigned. Now let's do one thing. Let us stop the radvd so that it doesn't send any more advertisements. Now let us go back to the client interface, clear the screen, delete the IP address again, and then wait for a second or two, and then do IPA, and then you would see that the IP address is not assigned now because there are no router advertisements being sent. Now we can do one more thing. We will just enable a TCP dump on the client interface to see what are the bunch of messages that are being exchanged on these interfaces. So let me clear off the screen again, and I will just run a TCP dump on the interface which is called ETHCR. Okay, and of course I need to run with some permissions. All right, so now this is listening on ETHCR and it's waiting for the packet exchanges to happen, and this is the client interface. Let me go to the router interface. I will start radvd once again. Once I start radvd, I can go to this particular interface and I can see that the router advertisement messages have started appearing. And if you wait for some more time, you will see the neighbor solicitation message which has come up now. You can see that. And once the neighbor solicitation is exchanged and the IPv6 address is assigned, the router advertisement messages continue to come, and they keep coming at a specific interval. Okay, so basically you can see that these packets are now getting exchanged between the two interfaces, and you have successfully allotted an IPv6 address to the client. What we can also do is, I'll just cut this and I will transfer this entire thing into a PCAP. But before I do that, I need to stop my radvd so that it doesn't send any packets while I enable the capture. Let me go and delete this IP address which I assigned, and now I will redirect the output of my TCP dump into a file. I'll just call it as client, where I'm assigning an address through slack.pcap, and just count maybe 5 packets. We don't capture more than 5 packets. and capture it on the Ethernet, which has the device name as ETHCR. And now it's listening, and now I will start RADVD. So once I start RADVD, again the IP address is assigned, the router advertisement messages will be exchanged, and then once sufficient number of packets are captured, it will dump all of this into a file. You can see it has dumped into a file. What I can do is I'll just do a simple SCP and take out this particular packets on my local machine so that I can play around with them, and then I can see what is going on in that. So give me a moment and I'll pull this. Okay, so I need to hide this. All right. All right, so we have this PCAP now available with us, and I can just open it. So it will take a moment, but basically the idea is we want to see the same messages what we saw on the TCP dump. You can see these messages that are there in front. So the first message is a router advertisement, and it has been sent on the multicast group ID, and you can actually click on this particular packet and we can verify what was the content inside this particular ICMPv6 protocol. So you can see that there is an option field which is clearly telling us that there was a prefix information inside that, and this is the same prefix that we had set in our configuration file. You can also see that the lifetime which we see here is exactly what we provided in our configuration file, right? Let us go to the next packet in series. The next packet is the neighbor solicitation. So once I go here, I can open up the ICMPv6 packet and I can see what is the target address. And this is the address that we have assigned to the client interface. So there are a lot more things that we can do with this. Let me also do now one more thing, get back to my client device. I'll re-enter my client machine, and I will stop the radvd daemon again, because before I want to do any other changes to the configuration file, it's important that I stop the daemon. So I stop the daemon. I also go to the client interface and I delete the address which was given. I will now change the prefix in the configuration file. So let's go to the configuration file and change the prefix with a small thing. Let's call that, we will have this, instead of db7 we will call it as db8, we'll call it as db7. Just save the file and come back to the router interface. We can run the daemon again, go back to the client interface to see whether we are getting a new IPv6 address, and you can see now it giving an IPv6 address from the different prefix that we provided. So this is the simple thing that I was able to play around for this session, and I thought it would be important for me to show this. As I said, this whole setup which we have right now, it can be easily reproduced. Instead of 2 VMs, we can just we can use 2 network namespaces, and then we can do that. But of course, we will not be going into the depth of that, because we need to go to now the stateful DHCPv6, and there are a lot more things to see over there. For example, the lease file and the log files. So let me do one thing. I'll go back to my presentation, and this is the point where we had stopped. And these are the commands that we already discussed, which are also put up in the slide. So we already went through this command, which is noted on point 5. We looked into TCP dump and looked into the ETHCR interface. We also captured it into a PCAP file. We opened up the PCAP file and went through different packets. Then we went to radvd configuration file, which is in etc directory, and then changed the prefix. We restarted the radvd and we verified that a new IPv6 address is allocated on the client interface. So with this, I would now take the session into a different direction. We would now talk about the address assignment using stateful DHCPv6. I have a different setup ready again. So we will call these 2 devices as client and server. And the server, in my case, will also do a bit of the functionality that the router does. That's, for example, sending out router advertisements. But in real setup, we know we have separate devices that do the router advertisements, and the DHCP server is running on another specific machine. So we will call this interface as a client to server interface, which is called ETHCS, and then this is called ETHSC. And I have set up again 2 separate VMs for playing around with this experiment. We can use the same VMs which we had, but I didn't want to create too much of confusion by swapping the configuration files here and there. So I have just maintained 2 separate test beds for showing this experiment. We will go and see what are the configurations that I have done. These are all already completed in this particular session. I'm not going to do that, but just for the information of everyone, what are the steps that I followed to reach to a point where I can actually see the stateful allocation of the IPv6 addresses. So first thing, as I said, there are many tools that you can use. For example, Dibbler is very popular, even Kia is very popular, but I chose a very simple ISC DHCP server package, and I downloaded it from the URL which I have specified here in the presentation, and I just picked up just in case if anybody wants to know what was the release or what was the version that I used, because you might want to repeat this experiment after this session someday. It was 4.4.2-P1. The release date was May 2021. So it's a pretty recent release, and it is the most stable release, the latest stable release as of now. So once I downloaded that, I did typical steps. I just unzipped the file and went into that directory and ran these 3 commands which you usually do. You don't need anything extra for the /configure. We just need to have the basic C compilers and stuff like that, which I could manage to I just gave build essential package installation, and it just got all the necessary things for me. And the installation to just let you know a little more details, that the installation was relatively straightforward. There wasn't too much of an hassle to install it, so maybe you can give it a shot. I'm sure you wouldn't face any problems because the installation was not that difficult. And after we do that, we need to now update the radvd configuration, because if you see what we are going to do in this radvd configuration is that we are not going to allocate the prefix here. That will be something that the DHCPv6 server would provide. But the router advertisements, as I said, because these are just 2 virtual machines and we don't have a dedicated router machine, we will be using the same server interface to also send out the router advertisements. Now, this might not be needed otherwise, but we have kept both the options, and we will play around in the hands-on in both the options. We will use radvd as well as we will skip radvd and see that it works either way. Now, if you just want to compare this particular configuration file with the previous one, let me just go back in my presentation, and you can see this was the previous radvd configuration file that we had, in which we have a prefix specified, and the interface name was ethrc. So interface name will change, and we don't need the prefix, but there are some other important flags that are crucial for us to use radvd along with the DHCPv6 server. So let me go to the new configuration file. In the new configuration file, you can see that we have a new interface which is called ETHSC because of the naming convention that we changed here. All right, and then the 3 first parameters that you see are exactly the same that we had even when we were talking about address assignment using SLAAC. But there are 2 more that we have added, and those are the ones which are important. The 4th one in the list you can see is called managed flag. And when you turn it on, you are actually informing in your router advertisements to all the receivers of these messages that the address allocation is done in a stateful manner. And typically, this flag is off when you are doing it using SLAAC. So when I did the experiments and when I showed certain steps few minutes back, this flag was off by default. And it's off by default even otherwise. So we need to turn it on whenever we want to use radvd along with the DHCPv6 server. If you are not using a DHCPv6 server and would just like to do a stateless auto configuration, that means stateless address assignment, you can just leave this as a default setting. You don't need to mention this in your configuration file. But one important thing along with DHCPv6 is that we don't only provide the IPv6 addresses. There are other details, other parameters that we specify. So if, for example, we might want a default gateway information or other informations. So basically, if you would like all those informations to be also advertised, basically you say that other configuration flag should also be turned on, which allows the stateful allocation of other parameters. And we shall see soon in the next slide the configuration file that I have created. You can see in step number 3 at the bottom of the slide, we have to create, like we created an radvd.configuration file, we have to create a DHCP daemon configuration file. So in that configuration, there are other things that we will be putting. For example, what is the prefix? What is the DNS detail? What is the IPv6 address of that server? What is the domain name of that server? We will also specify what will be the time period for which this IPv6 address will remain valid. That means I will maintain the lease file in which I will specify this is the time that I allotted the IPv6 address, and then it is valid for so much amount of duration. So this is radvd.conf file, and after this presentation gets over, I will be sharing this configuration file as well as the one that I used for my previous demo. Both of these, along with the DHCP daemon configuration file and all other necessary information that you need, I will be just putting all of them into a directory and sharing it with Nalini, and you all will get all this information. So need not spend too much time on this, and we can go forward and talk about how does the DHCP daemon configuration file look like. So in this, the first thing we have specified, of course, there are many parameters that you can put here. For a very simple presentation, I have kept this. The actual configuration file can be much more complex than this. This is actually very simple. So the default lease time that I specify is 600. Again, the unit is all in terms of seconds. And then there is another parameter called max lease time. So the max lease time is basically when a client requests for the specific lease period, but we as servers want to provide maximum lease time up to a certain time, then we will say, okay, that this is the parameter that will come into picture. So even if the client requests for more, this is the maximum lease time that we will grant, not more than that. And that's again, the unit is in seconds. As we discussed just a few minutes back, logging is extremely important when we are doing stateful DHCPv6. We always want to know if something went wrong, and if it did, how do we fix it? So we enable the log facility here. I will spend some time at the end of this presentation to actually show you some log files which we will generate. And I also have some snapshots about the sample log files that I collected before this particular session. Just in case if something goes wrong, we should have a backup. After this, we specify the prefix that will be used, and we specify the range for the clients. So we specify what is the range in which we want to assign the IPv6 addresses. And then these are the additional options for which in the previous slide we had turned on this particular flag, because we said we want other things also to be shared and done in a stateful manner. And then you can see that we have two options here. The first option is about the name servers, the IPv6 address for the name servers, and then the domain search. So these two things we will also be able to see in the packet captures. When we see that the packets are getting exchanged between the two virtual machines that we have set up, we will be able to see that this is the information that is shared with both of them. One more important thing before we actually run the DHCPv6 daemon is that we need to create a location where our lease information will be stored. And it might happen that you don't have this DHCPv6 domain, the daemon configuration file. You might have to create it. I had to create it for myself. It wasn't there. And in the same way, I created leases in this specific location, //db/dhcp-daemon.leases. So it is important for us to specify that, okay, this is the configuration file and this will be the content in it. This file has to be empty. We shouldn't write anything into this. Once we run the experiments, once the server exchanges the information to the client sends a solicit, server sends an advertise, and they send a request reply messages. All of that information will be stored in the log, and the IPv6 addresses that are given to the client will be stored in this leases file, along with the information that which IPv6 address is valid for how much period of time. So we shall see the leases also in some more time from here. Let's proceed with the next steps. So the next step is if we want to use radvd along with DHCPv6, then we have to start radvd service once again. But as I said, it is not necessary. We can also keep it off, and we can just run the second command, which is enabling the DHCP daemon service. And we start that service on a specific interface, and you can see it is SC. So this is going to be from server to client interface. So server will be running this daemon. And then once we run it, we will go to the client VM and then the client will seek IPv6 addresses. So when we run this command, which is provided in step number 3, it will actually start sending the solicit message. And the server is already ready, listening on port number 547, which already is something that Nalini has discussed earlier. So the request will come from the client, the solicit message will come from the client after we run this specific command, and this command is run on the client VM, and hence the client interface is provided, which is called client to server ETH-CS. So once we run this, after that we should be able to see that an IPv6 address is assigned to the client machine. We should also be able to go to the server machine and open up the lease file and see what is the information provided in those lease files. So let me again take a break here from the presentation. I'll jump on to showing the demo. Then again, I will come back, and we have some sample lease files put up in my machine here already. So we will analyze each component which is there inside the lease file. So let me swap over to the thing, and let me come out of this machine and go to my another machine in which I have the stateful DHCPv6 configuration ready. And okay, so right, so now you can see that I'm on this side on a server machine, and then I have another one which is a client machine. Let us do some quick checks on the server side before we run. Let us verify we have our radvd configuration intact for this particular experiment, and that we shouldn't have the prefix mentioned over it. So once I open, you can see that the interface is mentioned, and the basic parameters like minimum time interval between the router advertisements and maximum time interval. And you can see that in this case, I have turned the send advertisement off, in which case I wouldn't be sending the advertisements. But for this experiment, first let me put it on, then I will put it off. So first let's change this and say we want to send router advertisements from the same machine on which we have the DHCPv6 server running. And I have put up the manage flag on so that everyone knows that, okay, the addresses will be assigned in a stateful manner. And this is for providing other information besides the IPv6 addresses. So let's come out. We have verified that the configuration file is intact, but we should also look into whether we have the DHCPv6 daemon configuration file ready. So let's go to that path which is specified in my presentation, and this is the file. Let's open up and see what are the contents inside this file. So we have the default lease time, which I discussed. We have the max lease time. So just in case if the client is requesting for a specific lease time, we can decide whether it falls within our limit. If it falls, we can assign that lease time. Otherwise, we can maximum assign to 7,200 seconds. We have enabled the log. We have specified the prefix. We have specified the range for the clients, and we have the name server's IPv6 address and domain search. All of this was exactly the same which I presented in my slides. The same thing has been put up here. So we have verified that we have the DHCPv6 daemon configuration file. One more thing we should verify is whether we have the leases file or not. I'm not going to open that because there are already some leases, because I was playing around before the session and it might be confusing, but let us just see whether the file exists or not, right? So what I'll do is I'll just see whether that file is there. And sorry, I should be going into this path, and yes, the file exists, and it should be an empty file. It won't be an empty file right now because I was playing around before this session started just to see that nothing goes wrong in the presentation. So the file exists. We will open that up later and verify it again. So everything seems to be fine on the server side. We don't need much on the client side, right? So let us do one thing. Let's go to the client interface. So we are on the client virtual machine now. Let us see the name of the client interface. You can see IPA. Okay, the interface is called ETHCS, and we have an IPv4 address assigned to it. We also have a link local IPv6 address assigned, but we don't have an IPv6 address which has a global scope, right? And that's what we are going to do now. We are going to run the DHCPv6 server, and it will assign the addresses to the client. Okay, now I have chosen certain commands, and based on, I mean, those commands are also specified in the presentation in case you would like to see them. now I'm going to run these set of commands. I'll start with the first one and second one on the server machine, then I'll go to the client machine and I'll trigger the client. In the real world, we don't do that. Typically, our clients, when they connect to the network, they start sending out the messages if everything is enabled. But here we will do it in the experiment because these are just virtual machines that have been set up for the experimental purposes. So let me go back. I'm on the client one. I have ensured that there is no IPv6 address right now. Let me clear this off. Let me go back to the server machine and let us run the first step of the presentation. That is, we should start radvd. So I will trigger radvd, and once I do this, let us go and verify whether the router advertisement messages have started coming or not. So we can go to the ETHCS, that is from client to server interface, and then you keep listening on it for a while and you can see that the router advertisement messages are going on here. But IPv6 address will still not be allotted because the DHCP server, which has the actual prefix information and the client range, we have not still switched it on. So this is just a router advertisement. Let me cut this. And now, while the radvd is running, I would like to run DHCPv6 server. So the same command which we saw in our presentation is here. Okay, so this is the DHCP daemon. We are giving a bunch of options, -6 for IPv6, similarly CF for the configuration file that we have, and we are running it on a specific interface. So once I run this, you can see that it says server starting service, and now the server has started. Let us go to the client interface, and we should also now trigger the client to request for the IPv6 addresses. So the command for that, as specified in the presentation slides, is this one. You can see that it's here. So DHC client, DH client, and with a bunch of options with the specific interface on which we want the IPv6 address to be assigned on the client machine. So let me run that file, run that command, and you can see now there are a bunch of messages that are popping up. Even if we look at this, it gives us a decent amount of information, but we will still go to the PCAP. We will also open up the lease files. We will also open up the log file. But if you would like to see, you can see certain messages tell us what's going on. So this is Solicit going on. After this, we can see there is Advertise message that's coming on. Then after a while, you can see that the request message is being formed. And then finally, the reply message is being sent. So if you would like to verify now, let us do this, and you can see that now a new IPv6 address has been assigned with a global scope from the DHCPv6 server. Let us do one thing. Let us go and take a look at the lease file now. So we know that client has been given an IPv6 address through the DHCPv6 server. We don't need the server to be running. I will stop the server, but still you can see we stopped this terminal when this was the last line, server starting service. And after that, even the messages here give us quite a bit of an information of what's going on. So you can see that the server received a solicit message from a link local IPv6 address, port 546, and this is the transaction ID. And then it's picking the pool, from the pool the address, and then it is sending an advertise message saying that it will be valid only for 600 seconds. You can also see the DHCPv6 unique identifier being specified here on the terminal. All of this will also be available in the log files and lease files, but still I'm just mentioning here so that preliminary check can be done by looking at what's happening, and these are also some easy ways to understand whether things are happening the way we expect them. And then you can see there is a request message coming from that IPv6 address on this from this port, and then there is a reply message that is being sent, and then the reply message is actually sent. This is like forming a reply message and then sending the reply message. So now we don't need the server for now. We can stop it. We can instead go to server's lease files and see what's going on. So let me open up the lease files. All right, and you can see there's a bunch of information over here. So since there were so many experiments that I was trying, there are multiple entries into this lease file. And what I have done is I have just picked one entry and then I have put up in my presentation. So instead of explaining things here by highlighting, I have already done that in my presentation. So let me directly go to the presentation and show each component of the lease file. So once we see this, this is a sample entry of a lease file. And the first one that you see is specifying what is the server's DHCP unique identifier. And that's highlighted in this particular slide. Let us go to the next one. The next one is called Identity Association for Non-Temporary Address. And this is presented in this line, which is highlighted in the presentation. The next line that you see, which you see is as CLTT. CLTT is actually client's last transaction time. That means what was the last transaction time that I saw from the client. And you can see I was doing this experiment yesterday before this session started, just to see that everything is in place. This is the lease grant time. This is the time when the lease was granted. And we know that the time that we are granting the lease for is 600 seconds, right? So if you do that, you will see that it matches with what is the end time. So exactly after 10 minutes, we have a lease expiry time. Of course, the client can send a renew message and then it can renew its lease. But of course, that's not explained in this slide. That's a different thing. I have not covered that as a part of this session, taking the time into consideration. But yes, this is how the information is there in the lease file. There is one more thing. This is the address actually, which was assigned. The binding state is currently active. If you go to certain leases, I'm not sure whether that's true right now, but yes, you can see that this is another experiment that I was doing and it says binding state is expired. I don't have that in my slide, so I just came back to my current lease file, and this is entry from again morning time in India when I was trying certain experiments. So since I shut down the server after the experiment was done, even if there are any renew messages that were sent, will not be responded by because there was no server running, and that's why the binding state expires. But here in this slides that I am showing, we have binding state which is active. Okay. Apart from that, you can see there are other things which we specified in our configuration files, and they are reflected in the lease files as well. So this is a brief walkthrough of the lease files. Let us also go and look at some of the PCAP files. So again, I will now go to my machines. I would come out of this. So I haven't stopped the radvd, it's still running. So let me stop it, because otherwise all these messages will be captured in the packet trace that I try to get from the client interface. So we are at the server side. I have stopped the DHCP server already. Sorry, this is lease file. Yeah, but this was the command. So I stopped this server already. This service is already stopped. Now I have stopped the radvd service as well. What I need to do is, before I turn anything on, let me go to the client interface. Let me pick up the address which was assigned by the server, and let me delete this particular IPv6 address so that a new one can be assigned. So first of all, let me clear so that it's visible to everyone. Okay, so I deleted the IPv6 address that was assigned, and I will now try to switch on the packet capture, and I will call it as, put it in the client, and this is a stateful allocation, so I should be able to have a different PCAP file. Count maybe 10 packets should be okay, because I don't want to give 5, because 4 of them are just solicit, advertise, request and reply. So let us give little more. No, nothing wrong in having bigger file, but just transfers will take time. Switch it on the interface, which is from client to the server, and it's listening now. So what I'll do is I'll start the radvd, and then I'll start DHCP. In the other file, I'll open up one more tab, and I'll go to my client interface. Just to avoid any confusions, I will open up this separate. Okay, and I will just type sudo dh client and on the interface that I wanted to run. So once I run now, you can see that the messages are getting exchanged. All of them will be captured here. It might have happened that this has already captured the radvd packets and they don't have any DHCP packets. Let us take a moment. I will remove this. I will again delete the IPv6 address which was assigned by me here. Okay, so that, and I will do one more packet capture. Okay, sorry for that, because I think all 10 packets were captured for radvd itself, because I took time to log into my another terminal and show that. So I will open up one more. Before that, let me stop the services on the server side. I don't want them to be running when I start the capture. Okay, so my server is blank, not doing anything. I will run the DHCP client here. I'll do the packet capture here. So I'll change the name and I'll say new. Let me capture a little more packets. There is no harm in doing that. Okay, right. So I start the capture. I start the radvd service. I start the server, DHCPv6 server. Now I will run the client, right? And you can see, because we were running this client again and again, there are no messages that are exchanged here because the leases are still active. And if you see that, it just says that, confirming active lease, you can see here. So we will have to actually remove all those leases and then see how the advertisement message is exchanged. But never mind, whatever is exchanged here, we will open in the pcap file. I have another pcap file to show, wherein I can show that those messages were captured. Okay, so let me stop the client as well, and now I can stop the server. I will bring this pcap to my local machine, and then we can take a look at what was the content. We might not see the actual 4 messages because I already have completed that exercise and showed that on the terminal that message IPv6 address was allocated. Leases are still active, so it's just saying, okay, the lease is active. I don't need to give a new IPv6 address, and the client is also not sending a new solicit message because it has an IPv6 address and it's intact, right? Okay, so let me go back to this machine and then capture this pcap. Okay. All right, so let me, I think I did some typing mistake. Okay. Right. So we have this new pcap. All right, so you can see that these were the messages exchanged. We didn't see the solicit, advertise, request and reply because the lease was active, it had not expired, and that's what is shown here. Let me open up another message which we have already with us. So give me a minute. I have kept some pcap files ready just in case we need them. So let me open up this one. All right. Okay, so you can see here, this is the capture, and let me verify. Yeah, okay. So you can see that this is the solicit message here. You can open up the DHCPv6. We can see the transaction ID, which is something that Nalini was explaining in the presentation last week. And then we can see what are the other options that we have. So let me quickly go through so that I don't take too much of time. We have only a few minutes remaining. Okay, so this is the option request. You can see here, in which there are so many other things we have. Let me directly go to the advertise. So you can see in the advertise we have the same transaction ID that we had for the solicit. This is the IANA. Let us go down and see what is the IPv6 address actually being picked up, what will be the valid lifetime for it, what is the preferred lifetime. These both settings are again same what we had in our configuration files. This is the client's DHCPv6 unique identifier, and it also tells how this DUID was taken up. So you can see link layer address plus time was taken up to obtain this. This is a server DUID, and this is the DNS recursive name server, and this is the same IPv6 address which we had provided for the name server. And if you open up the domain search list, you will see example.domain.example, which I had put up in my configuration file of DHCPv6. Then similarly, this is the request message, and it will have a different transaction ID. And when I go to reply, we will see that the transaction ID matches with the request transaction ID, and we can do a bunch of more analysis here. Now, whatever I showed in this PCAP, we have that also in our presentation as the last part. I have already specified this. Now, as the last thing, let me open up the log files. Okay, so that will be the last step, and then I will stop talking and then see if we have some time for taking some questions. So, what typically we see is that when we enable the logging in the configuration files here, it basically goes and writes everything into syslog. Now that might not be a good idea in reality, because you might have logs which are very big in size. You might not want to keep them on the same machine. You might want to redirect them to altogether a different machine where you keep your logs. All those possibilities are there. We can have Splunk installed and it can manage things for us. But I have taken a very simple alternative is I just do a simple grep. I fetch out whatever is there for DHCP daemon from the syslog and I put it into the DHCP log files. And I have some snapshots of those log files here. So this is it. And if you would like to capture them live, we can always go back to the terminal quickly, go to the server interface, and we can say, okay, maybe just do a grep of whatever you see with DHCP daemon from the syslog files and put them into DHCP log. And then I can open up this DHCP log and you can see this is all that my log has. But of course, it's difficult to look at it this way. So I would prefer to go it in the presentation and explain. So let us see here. Okay, so this is the first thing. In the log, these are the pointers to our important files. You can see it shows us where is our configuration file, where can we find our leases, and in case we need the process ID. So these are the necessary files that are a part of the log. This is the server port number to which the requests are received for DHCPv6. I mean the IPv6 addresses from the client side whenever we are using stateful DHCPv6. And going further, these are all the messages also which are logged. For example, the solicit message, where did it come from and which port number. So you can see it's 546, which is a client port number as explained by Nalini. And you can track this. If you recall, these were the messages also that were getting printed on the terminal for us, but then these are all stored in the log and we can always visit it. As I mentioned that I'm not going into the complex processes of storing the log files. As I said, another alternative is that we redirect the logs altogether into a log file by directly editing the syslog configuration. But I didn't want to go into those complexities in this presentation. So I just took a simple approach of doing a grep and showing that these are the logs that can be useful. That's all from my side. Thanks everyone. I hope it was useful. Back to you, Nalini.
Oh, that was wonderful, Mohit. Really, really good. We just have time for one question, but it's a super interesting one. The question is about the radvd daemon. I make sure that we have a pointer or download link to that, because the question is, okay, so say I have the radvd daemon and I bind it to the public interface on a host in a data center. So are you telling me then if I have that, then I'm going to get, like, other servers, VMs on that link are automatically going to get configured with SLAAC?
Okay, I think I need to. Okay, I think I didn't get the full part of the question, but okay, if there's I would like to. Okay, I can see the question. If one would configure the RA daemon to bind to the public interface on the host in a data center, that would mean that the other server's VM on that link would be configured by my server. If SLAAC is, yeah, so basically, typically what we do is we have the router machines which do this stateless auto configuration for us. So this is just a software running in, but yes, if on any interface, if we bind this radvd to run, it will give IPv6 addresses itself to all the devices that are on that same link. Yeah, it will.
Yeah, no, that's very, very interesting. Now, of course, as Mike said before, you have to think about your, if you've got firewall, and stuff like that, you know, because you may be stopping your router advertisement. But yes, that's a very interesting. So given that your firewalls are configured to allow that, then sure. So great. This was really wonderful, Mohit. You went through a lot of information, and which was absolutely wonderful. And we will be sending you the PCAPs that Mohit did, as well as the log and other stuff. And I think that will be very, very interesting for everyone. So, so thank you all so much, and we will see you at the next presentation. And thank you again, Mohit.
Thanks, Nalini. Thank you, everyone.